Hello, this is Griffin, and we're going to be doing my physics problem today. So, a foam ball is shot at 75-degree angle at 9.65 meters per second towards a high goal. So what we're going to want to start with is our 75 degree angle and 9.65 meters per second. The high goal is a rectangle from 3 meters at its lowest point. So let's just draw a logo here. It's like 3 meters. To 5 meters up at its highest point. So we have 5 meters here, and this is our goal. The ball is shot from 0.3 meters up. So 0.3 meters. And 2 meters away from the goal horizontally. So that's a 2 meter displacement. Will the ball enter the goal, and at what speed, in what direction will it be traveling? So obviously the first thing that we're going to want to find is the velocities, the components of this, so the velocity horizontally and the velocity vertically. So with 9.65 cosine 75, we can find the horizontal velocity, which if we do that out, it happens to be 2.498 meters per second. And with 9.65 sine 75, we can find the vertical velocity, which happens to be 9.321 meters per second. So those are our initial velocities. Now, what we're going to want to find next is the time that it takes for this to reach 2 meters past. So if we were to do a normal equation, we would do, like say, negative 9.321. So that's the final velocity minus the initial velocity. This is during the second half of the fall, divided by the acceleration to find the time. So negative 9.8, which equals 1.902 if we multiply that by 2 to find the other half. But that's not what we want. What we want is the time that it takes to reach 2 meters. So if we take the horizontal velocity, 2.498 meters per second, or if we're going to do this in unit analysis, meters seconds, divided by 2 meters, so the time that it takes for it to travel 2 meters will get us 1.249 seconds, because these meters cancel out. Alright, so next we're going to want to find out, like, during this time, how high did it go? At what height is it? Is it up here, is it up here, is it up here, or down here? So we're going to be using, for that, well, before we do that, just going to point out, because we're 0.3 meters up, this goes down, so 4.7 and 2.7 is our goal now, so somewhere in between there, because we're now doing this equation as if we're on the ground, so these move down accordingly. So in order to find how high it goes, we're going to need the displacement equation, which is displacement equals VI, the initial velocity, times the time, plus the 1/2 acceleration, which is g, times the time squared. So for the velocity initial times the time, that is that's going to be 9.321 meters per second times 1.249 seconds. Seconds cancel out, and that leaves us with 11 9.64 meters. Now for 1/2 g times t squared, that's 1 over 2 times 9.8 meters per second squared, which of course is times 1.249 seconds and another 1.249 seconds. And that gives us, since this is a negative, that's going to give us negative 7.64 meters. Add those together and we get 4 meters. Approximately, because these are both rounding. So, since it's between 2.7 and 4.7, that means that we did make our goal. We're in the goal. We got a point. Yay. So now what we're going to have to find is at what speed and what direction will it be traveling. So what we're going to want to do is find the final velocity. So in order to find the final velocity equals velocity initial plus acceleration times time. Now for the horizontal velocity, that's going to stay the same because there is no acceleration, so this is gone. And it's just the velocity initial. So velocity final horizontally is still 2.498 meters per second. Now for the velocity final vertical, which is a little bit different, we're going to actually need to do this out. So our initial velocity is 9.321 meters per second. Now that's just going to sit there while we do negative 9.8 meters unit analysis seconds squared times the 1.249 seconds. And that will, since these not entirely cancel out, but that gives us meters per second, that will give us a negative 12.24 meters per second. Now if we add these both together, we get a nice solid negative 2.919 meters per second. That's some pretty quality numbers right there. Negative, and let's just fill in our nice little thing here so we can reference that. Alright, so what we're going to want to do now is find what speed it's going to be traveling at. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. I'm sure you all know. And that's going to give us 2.919, it could be negative, could be positive, it's still going to be squared, plus 2.498 squared is going to equal 14.76, which, if we take the square root of that, equals 3.842 meters per second. Delicious. So, it's going to be traveling at that speed. Now we need to find the angle at which it's going to be traveling, the direction, essentially, to the horizontal. So it's 75 degrees to the horizontal. Now how far to the horizontal will it be traveling when it passes through this goal? So say like right here. Now, to find that, we're going to need the inverse tangent of the opposite over adjacent, so negative 2.919 over 2.498. Now this will give us our angle, which will be a negative 49.4 degrees. And that's, of course, below the horizontal, so that's why it's a negative. So we're down here. This is 49.4 degrees from the horizontal down. So that gives us our answer of yes, it does make it through the goal because we got this nice 4 meters over here. And it's going to be traveling at 3.842 meters per second at 49.4 degrees below the horizontal when it goes into the goal. So it's going to go nice and down into the goal, and everyone's going to be happy, and you just won your team the game.